Good morning, everyone. Whoa, everything's so yellow. Hi. I hope you had a great... The hell? What's wrong with the frame? Okay, that's okay. We can be a little bit yellow today. I don't really understand. But that's alright. Um, nice to... I guess nice to see everyone. It's okay. It'll hopefully level itself out. Today we're going to be going through 2.4, which is like the packages topic, but even just before that, we're going to dig a little bit into that last little part of, what would you call it? Like the importing that we did yesterday. Just explain that just a little bit more, because I think there's like a tiny detail we missed out on yesterday. What that was actually just a single slide at the end of our importing lectures, which touched on this idea of relative imports. This is a pretty important topic because what this kind of, like a common question that students have when they're trying to make sense of Python imports is just how Python figures out like what to import. So for instance, yesterday when we were having a look at this, like we had a look at this like cal math example and this import to example. And you know, what was interesting about this example, right, is that with import to, we had this like import statement, or maybe I'll just keep things really simple. Let's just say import cal math, so they're somewhat equivalent today. And it's kind of like, how does Python know where to find this file, you know? Now, it makes a lot of sense when you're just like, oh, well, it's in the same folder, so Python should figure it out, I guess. But there's actually slightly more, I guess, complicated rules behind things that happen. Firstly, when you do any kind of importing in Python, Python looks in specific places or a specific place. There's actually a little Python file I've got here called like import sys, print sys.path, and sys.path is what you call the Python path, which is essentially a list of directories that Python looks for stuff in. So we're just going to kind of understand where Python looks to do particular imports. One thing you'll also see on this little code example here is that you can actually run Python directly in the terminal without even needing a file using the -c command. So for instance, if you just open up a terminal like this and you just say, let me just even get to the area. If you just say something like this, Python 3 -c, and then you just write print hello, Python will actually run that. It'll run like what's in the string. So we can actually figure out what the path is in Python pretty quickly just by putting import sys, and then we can actually use semicolons to say this is the end of the line. Bit of a surprise, I know, but you know, print sys.path like that. And what this will do is this will actually run the equivalent program here of import sys, print sys.path. And you can see there's a long list of stuff. We've got like an empty string, and then we've got some stuff here, and then we've got some other stuff here, and some other stuff here. And these are all different directories on this particular Linux machine. And with all these different directories, right, it's like, this is where Python kind of goes to figure out where potential files are. So you'll actually see the very first one here is the folder we're in. So what this kind of tells you is that in the order that Python actually looks for things, it looks first relative to the directory your Python process was invoked in. So that's like the first place it looks. And then secondly, after that, it looks like for all the other relative directories in the sys.path list. Now, they're all part of the sys.path list. Like, your directory is actually in the sys.path list, but that's kind of the only dynamic thing. All these other kinds of directories here, like this one and this one, these are all kind of baked into Python. You can modify them, but what these directories are is essentially common places on the computer that libraries are, and we're going to learn about that in the rest of 2.4, is like how to install more modules and more libraries. But that's kind of just where they're installed. It's like the program files folder on Windows. One of the important things to understand, though, is if I create a folder, say dud, and inside that file I create my my blah.py, which has my import sys and my print sys.path. If I say Python 3 blah, you'll see that I do actually see this folder here. It's, it's my folder, CS1531 content lecture dud. But if I go back a folder and I run Python 3 dud/blah, so I'm now running this file from a previous directory, you'll see that it also does include the path here, right? But it's also including the path I invoked the script from. Now, this is kind of important because when you're actually like running a particular Python command, when you're actually like running the Python interpreter, a common practice is to do all of your imports from the location that you're actually running the script from. Because kind of logic would dictate to you that it's a little bit like C in the sense that each import is kind of derived from the file it's in. And we've probably seen this in C, right? Where if you're writing a C-style program, and you're in this folder and you want to import something in the previous folder, then you kind of go like, import, in C it's like hash include ... something, In Python, we don't really follow that philosophy as much. We kind of follow the philosophy that in a given project, all of the imports are kind of meant to be done relative to one location. And you actually see that in the project too. So if I go and have a look at the project, and I just log into, I'm going to click remember me so we never have to do this again. If I go have a look at the project, you'll actually see this in terms of like the source folder and like the echo folder. I mean, even right here, right? Like all of these imports are importing from source dot error, right? So this is interesting because from this particular folder, you're already in the source folder. So this is relative to the project backend folder. So when you're actually doing your relative imports for files you write, you'll tend to try and write all of them in the project to the same folder. What's the benefit of this? Well, there's a few benefits, but probably one of the main benefits is that it makes your files more, what would you call it? It makes your files more versatile in the sense that you can easily move files around different folders without having to like redo the imports, because this file will be a valid Python file in essentially any folder you move it to, and that does make things a little bit more robust. So that's just a little comment on, I lost, did I leave the slides? Where'd the slides go? Yeah. That's just a bit more of a comment on that. What we're going to talk about with packages in a sec too is before it looks in your folder, and then before it after that goes and looks through all the other system folders. The one thing it does before all that is that it actually looks for any what we call like built-in binaries or like built-in libraries. Built-in libraries are things like sys, things like math. So at least I'm pretty sure it should do that. So like you can actually test this out yourself, right? Like if you go into the blah directory, right? If you actually say create another file called sys.py, which does nothing, just prints hello, and you go inside your dud, in your blah, and you actually try and import sys, what will actually happen here is that it will still import, I believe. I haven't tried this out in a while, so I might be mistaken, but I'm pretty sure it, yeah, so in this case, it still actually imports the Python library. It's not importing your library because otherwise it would have printed something. So above the hierarchy of importing is always the built-in. So things like sys, things like math, OS for operating system. There's like a few different libraries that you don't have to install. They're just like in Python and you can just use them normally. Those things are always priority 1. Priority 2 is any ones you write relative to your directory. That's where Python will look first, and then the rest is all the other stuff in syspath. Because Python literally goes through like the syspath variable and like just tries to see, is this file in here? Is this file in here? And once it finds it, it's like, that's it. I'm not going to look anymore. This leads us on to the rest of 2.4. So as I said, I've kind of wrapped this into 2.4, which is a topic on Python packages. Because again, when you're using Python more broadly, you want to typically use it more than just, I have some built-ins like math and sys I want to use, and I write my own files. There's actually a whole library of Python modules out there that you might want to use that help you solve a particular problem that aren't installed by default. So in this particular kind of lecture, we want to understand how to install these other modules that aren't in our system. And then we also need to understand how to manage these module installations in multi-user projects, because it's all well and good to kind of install things haphazardly when you're the only one working on things. But once there are other people working on things, you kind of need to figure out how to share what you've installed, right? So let's say you come along and you're like, oh, you install a particular library such as the JSON library. And then you need to tell your teammates. So you message your teammates and say, hey, I just installed this library. You should install it too. That's not a very scalable way to manage that problem either. So that's the second thing we need to talk about. So in terms of how to install libraries, Python comes with a number of standard libraries. E.g. Math talked about this. We call them built-ins because they are built into the language. In fact, most of those libraries are actually written in C for performance. So a lot of libraries that you will use, that you install like externally, I think a lot of those are written in Python, which means they are as fast as Python can be. But many of the libraries you use, like sys and math, they're actually written in C for performance reasons. Makes things really quickly. Like if everyone on the planet's going to use them, they might as well be as quick as possible, right? So while you do have a number of these built-ins, you may want to use many libraries you may want to use have to be installed. This makes sense, right? Again, many of you wouldn't have come across this concept in C because since C is a very simple language, you would have only ever really used what existed when you just had C on the system. Like even if you installed C yourself, you probably wouldn't have to actually install any external libraries. So these libraries are super easy to install due to a program. It's a binary called pip, P-I-P, and pip is a package manager, package installer for Python. Pip installs a particular version of a particular package, which is like a package you can find on the internet, for your system. Now there's two versions of pip out there. There's pip, just PIP, that's for Python 2, and then there's pip 3, which is for Python 3. So in this course, because we're using Python 3, we're going to be using pip 3. That's what we're going to be using to install all of our modules and stuff. If you were using Python 2, then naturally you would use pip. You'll probably use pip at some point in your life as well anyway, because there are still a lot of very old systems that rely on Python 2. But yeah, for this course, again, we're going to be using pip 3. So let's give you an example of an extremely popular library that you have to install. That library is NumPy. So NumPy is it's essentially like a mathy data. It's like a mathy library for people who are manipulating data that has a whole bunch of powerful stuff in it. It lets you create matrices and multiply them together, work with vectors. Like it's kind of like whenever you think back to doing your math at uni, it's a library that would help you solve those problems. And it definitely delves into like in the scale of like MATLAB to Python, it's like kind of somewhere in between. It's really trying to help you deal with some more fundamental maths. The thing is, if you'd like to use this library, if you'd like to run a piece of code like this, which is npy, which is npy.py, it's just the name of the file I gave it. If you try and run this one, so if we go inside of 2.4 and we run Python 3 npy, it actually, well, works for me at the moment because I've installed it. But like, let me, forgot to uninstall this before the lecture. Oh no, that's okay. I mean, I think I had this problem last year, but I'll give you an example if I say do this on my local machine, where I go and take this code and I just paste it into, call it npy.py, and I paste it here. And then when I try and run this, hopefully it's not installed here either. That would be quite an oversight. I get this particular error here, right? And this is the kind of error that you would see if you were to try and run this, which it says no module named NumPy. So that is the Python interpreter going to that import line, and what it's doing is it's checking if it's a built-in, number one. No, it's not a built-in. Then it's going and checking if there's any file in your current folder because that would be where the relative location is, called numpy.py, and it's like, no, there's nothing there. And then it looks through the rest of the, syspath. It looks through all of these here on my local machine, and it says, no, it's not inside of user lib python 3.8 / can I see anything with numpy there? No. Okay, so it's not there, right? So that's kind of what it's doing. And it looks through a whole bunch of other places. If it can't find it, it gives you that error and says it can't be found. So what you do then is you can install it. You can install it just by running pip3 install numpy. And what this will do is this will actually install numpy to your system. Now, if you're using the CSE machine, you can install these just by writing that out, because pip3 is installed on the CSE machine. If you're using your local machine, like I am in this particular example, you often will need to actually install pip. That is the command to install pip3, because you're installing the pip version of Python 3. It might be different on OS X, but if you're using any kind of Linux machine, that's like totally fine. So if I was to then try and install that, pip3 install bumpy numpy, it'll go and download it. So it's downloading the module for me to my computer. Great. So now when I run this, I get a different error. Didn't expect this error. I don't know. We're about to explain why some of this stuff is tricky. I'm just trying to install another library. Oh, you have no idea. That's so strange that it isn't running. I haven't actually seen that before. There's the question, is it given in this week's lab? I don't really know what that's in referring to. So like a common thing here, right, is, you come across an error like this, which is super weird. You Google it, you look this up, you try and read through some things, you might find a particular answer. You have your script named JSON. That's not true. We named our script NPy. Basically here what seems to happen is I've got some script somewhere on my computer called json.py that isn't behaving for me. So this is definitely something quite specific to my local machine, which is why we don't need to worry too much about it. Which is why, like on the CSE machines, like once you install it, it kind of just runs fine. Like if I just run Python 3 numpy, you'll actually get the output you want. And if you look at the program itself, you'll see the program is actually just printing the number of dimensions. It's in the number of like think about what a vector is, right? You've got like your 1D vector, your 2D vector from math. It's like this one has no dimensions, this one has 1 dimension, this one has 2 dimensions because it's like a 2D array, and this one is like a 3D array, so it has 3 dimensions. So, the NumPy library is interesting. There's not really much of a need for it in this course at all, but that's kind of how you would install it if you want to work with it. Now, after you've installed it, the real question is, where in the world do these things install to? So I go and install NumPy, and then like, where is it actually installed to? Now, typically, if you install something with pip3, whether it's on the CSE machines or locally, where it's actually installed is inside of your home directory. And, I'm no expert on this, but you'll see here, what we've got here is we have a couple of system places. So these couple of folders, particularly this one, are where like system level modules are installed for available use on all users. So if you have, say, a multi-user machine, which no one really does these days anymore, but let's say you have a machine that you share with your family and you've got a login and they've got a login, or even like the CSE machine where you've all got different logins. If there's something you install that can be made available to everyone, it's typically in a system folder like this, whereas a lot of other things we install are actually going to be in a folder like this one here. In this case, it's home/Hayden /.local/lib/python 3.8/site packages. And I can actually go and look that up. So I go to my home directory, .local/lib python 3.8 site packages, and if I just ls this folder to see what's in it, you'll see there's a whole bunch of stuff here, including numpy. So that's actually where NumPy was installed to. And you'll see if I pip3 uninstall NumPy, it asks me, are you sure I want to uninstall it? And then when I open this folder again, you can see that NumPy is gone. So it's actually installing the module to some random Python folder in my home directory. So it's specific to me as a user. If I want to install something globally, which you pretty much won't want to do in this course, but I'm just kind of giving you the full complete picture here. If you want to install something globally, then typically it might get stored in a folder like this one here. You notice this one isn't like in a home directory at all. So if I I think, where was it? Yeah, so there's a whole bunch of stuff here. So you notice there's no NumPy in this folder. On a Linux machine, the way to make a pip module be installed globally to the entire computer, say CSE could do this if they wanted to make something available to all of you, is you could say sudo, which is like the I'm an admin command, and then the exact same thing. So again, this is something that you can't do on the CSE machine. This is something that you don't want to do on your local machine. But I'll just kind of, for completeness, I'm just showing you where these kinds of different packages can be installed. And this is the same kind of thing for lots of package managers. You know, a lot of what we teach in this course with Python is just, you can carry the same rules over to many other languages. Like other languages have similar import rules. They have a system path. They have some kind of package manager. They're installed at they can be installed at like a local directory level or a global level or the one we're about to get to. But now I assume NumPy is going to be, ls user, what was it? Was it lib or was it bin? I think it was bin. Like we can just check the sys path again because we can actually see all the places it's looking for. So it's user lib Python 3.8. Let's see everything in there, and I just assuming there's going to be a NumPy there, but I don't actually know where this one gets installed because it's going to be somewhere else. So I don't think it got installed there. Doesn't really matter where it got installed, but it would be installed in some kind of I could just try all these out, right? Because that's literally what there you go, that's where it's installed. So it's installed in user local lib Python 3.8 dist packages. You can see it right there. If I was to sudo pip3 uninstall NumPy, we'd have the same thing where it's now gone from that folder. That's where it's installed or not installed. So we'll summarize that more at the end, but that's the point. Installing with pip, you can either install it to your home directory or you can install it to the entire computer if you want everyone to be able to use it. What are potential issues with this approach? Okay, so we figured out how to install some stuff, but two potential issues that we have are that even though we know how to install modules now, how do we easily share that list of modules that we've installed with our team? Because we have a team of people we're working with, like in the project. And how do we ensure that your project doesn't accidentally end up using modules from other projects? That's an interesting one. I'll give you an example. I think I have NumPy installed here. Let's try this out, NumPy. Typically, whenever you run a, or I can actually invoke it like this, I believe, NumPy version. Will this work? No, I totally broke this on this machine. But typically on the CSE machine, if you have something like a NumPy installed, and you do -- version, nah, it doesn't like me. You can find out every module you install has a particular version. In fact, if you look up say pip NumPy on the internet and you go and find where it's this is a bit of information about it on a site called PyPy. Typically you can actually go and have a look at a release history, and there's actually all these different versions. So you can see if you install NumPy now, you're probably installing version 1.21.2, which was released last month. But there's all these other versions here. There's all these other versions that different people might be using. And you might ask the question, why does everyone not just use the latest version? So when, say, NumPy releases a new version, why doesn't every single person in the world using NumPy just upgrade? And I mean, the answer is pretty simple. It's because sometimes you're using other libraries, and those other libraries don't like newer versions of NumPy because there's something different about it, or maybe they use a newer version of Python. The compatibility is a very touchy, complicated thing. So quite often out there, and I see this in my own projects too, is not everyone is working with the latest version. If you're starting with a new project, you're probably going to use the latest version. But for instance, one of the major libraries I work with at work I think it's like version 12 or something, and we're sitting on version 11, and we've tried to upgrade to version 12, but it just isn't quite working for us, so we're staying on version 11 right now. And this is a really common thing that happens. So a problem that we can run into is that if I'm installing, say, something like NumPy to my local directory on Hayden's machine, what happens if I'm working on two different Python projects, maybe a lab and the major project for 1531, but they want different versions of a particular library. One of them wants a newer version of NumPy, one of them wants an older version of NumPy. Or maybe you're working on this course and then you're helping out with a CSE SOC project, or you're doing some part-time work or some volunteering work, and they just want different modules. We need to solve this problem of kind of managing different versions of different modules and figuring out how to share these with your team. So this is where the idea of virtual environments comes in. And virtual environments are it's a concept, but the virtual environment with Python is a tool that we use to help keep dependencies required by different projects separate by essentially, instead of, you've kind of got these two tiers we've talked about, like you've got your whole system, your whole computer, you've got your local directory for your user, where all your projects inside of your user have that particular module and version. And then inside of that, what we want to do, which is the third layer that Python virtual environments gives us, is want a little box where we can work on just a single project. So if you have 3 Python projects on your CSE machine, you now have your login account, and then you've got 3 separate little virtual environments. You can read more about virtual environments here. There's quite a lot you can read on them. You're not going to get asked any... you might be asked about this on the exam, but you're not going to get asked to use it on the exam. Like, we're not going to ask you to be like, create a virtual environment. And we're going to talk through a few more things that explain why they're super useful. But we're actually just going to kind of run through a little demo. And it's really important that I've showed you where these Python modules are installed already, so that you can kind of get a sense of like how and why this works. In week 4, I believe Jake's going to take this lecture. We're going to install a particular library for use in the next iteration called Flask, and I'm just going to uninstall this from the CSE machine for me, so I can show you this particular, so we can run through this problem. Now, to work with virtual environments on your machine, there's a series of steps you follow. The first 2 you only have to follow once. The first step is to install the virtual environment software. This does not create a virtual environment. It installs the software that lets you create a virtual environment, right? Then the second line here actually creates a virtual environment on your machine. It says, I would like to create a new virtual environment in this particular folder. You only have to run this once on your system, and you only have to run the second one once per project. The next lines are something that you might want to do more frequently. So let's just start with the first 2. We have pip3 install virtual environment. So let's say for a second that I'm going to create a new folder, and I'll call it like project 2. So this is like a different project to, say, the major project, because I want to work on something in parallel. So I go inside my project 2 folder. In fact, I don't even need to be here yet. But the first thing I need to do is actually install the virtual environment software, which will allow me to use virtual environments. Goes and installs it from pip3. This will actually install for you the virtual environment software on your local directory, because remember, that's what pip's default behavior is. Pip's default behavior is to install things in your local directory. So then what I'm going to do is I'm going to, in my project folder, run the next command. And what this particular command does is it invokes the virtual environment module. It says, then I want to create a new virtual environment in this project, because all the kind of magic and nuts and bolts of a virtual environment for your project are actually stored in a folder somewhere, and that folder here we're defining as VENV for like virtual environment shorthand. So I can run that now in my project folder, and it will go and create one for me. So it created a virtual environment for me just then, and if I type ls in this folder, you can see I've got VMware here. in fact, maybe just for completeness, what I will do, I'll take a step back and we can do that again, is I'm actually going to go and create a, well, let's actually do one better. We had this repo earlier called lecture demo. That I think we used like last week. So what I'm actually going to do is, because this will be like your own projects, right? Because many of you will not have been using a virtual environment so far, naturally. So let's actually clone and use that one. So let me go back and let me just clone this. And let's pretend this is your project repo and you're trying to get a virtual environment set up and installed. So a few questions. Justin says, what do the colors mean on my terminal? I'm not 100% sure on the specifics. NK Pro again said, is it given in this week's lab pip3? I still don't quite understand this question, what you mean by is pip3 given. Pip3 is just a command line tool. That's like kind of asking if Git is given in this week's lab. And then Waleed says, wait, do you mean local directory or local user? Because why would we need a virtual environment if everything is always limited to the scope of our project directory? So in terms of that, when we install Python modules, they're available for the entire user account, which in this case is like hsmith or myzid. Right? And what we're going to do is we're going to create a virtual environment inside of it so that we don't get kind of polluted by everything else in the system. So let's just have a look at that. So if I run in here to, I've got my lecture demo folder, and let's go back to our virtual environment instructions. As we said before, you only have to run this once on the system, and then to create a virtual environment, you can just run this command. So I'm creating a virtual environment in the VM folder on this system, and now it's created, and if I press ls, you'll actually see that there's another file in this folder. So previously there was only a readme and hi, and now you can see there's actually a VM folder, and that VM folder is kind of where all the magic happens. Yeah. So my virtual environment is created now. It's created, and that's just kind of existing there. The more important step now, and this is the thing you're going to have to come back to every time you work, is that to kind of start up or like spool up or whatever your virtual environment, you need to run this command here, which is source/vm/bin/activate. And this has to be run from your project directory generally. And then when you're finished with the virtual environment, you run deactivate. So that's kind of like the start and stop commands. So here I could say source vm bin activate, and this will start my virtual directory, my virtual environment. And you can see it started because it's got this little VM thing at the start. So now I know I'm inside my virtual environment. And then when I'm done with it, I can run deactivate, which will kind of stop it. Now here's the interesting thing. When I am outside of my virtual environment, one command I can use, which we haven't used to date, is this command pip3 freeze. And what pip3 freeze does is it actually gives you a list of all of the modules installed in your current environment. Now, by default, my current environment is just my own local user login, which we've set as like hsmith. So if I say pip3 freeze, this shows me all of the modules installed on my hsmith account. And you can see we've got all these different ones here. These aren't all ones I've necessarily myself installed. Some of these are modules that modules I've installed have used, because people who write modules actually use other modules, and they use other modules. So there's kind of like a recursive tree effect here on the installs. But these are all the different modules that exist that I could use, that I've installed on my when I use the phrase Waleed home directory, it's like like local directory. The point is that they've been installed locally, as in my user account. They've been installed in a directory there. But watch what happens when I activate the virtual environment, and now I run pip3 freeze, sorry. I'm actually going to get an empty list here. And what this is saying is that something is not installed here. So to use our example earlier, if I deactivate that virtual environment and I create a file like npy.py, and all it's going to do is import numpy, and I run it normally here, it's going to fail because oh, I'm a VLab. No, it's all right. And I run this will work fine because numpy is installed because it's in the list of things installed on my user account. But if I activate my virtual environment and then I try and do Python 3 numpy, it's like, where is it? And then if I want to install it, I have to go pip3 install numpy, like this. And now where that installs it to is actually inside the VM folder. So it's not a system folder, it's not my local directory, it's now a project folder. So if I go into VM and I look at lib and I look at Python 3.7 site packages, you can actually see numpy is installed there. So now when I run Python 3 numpy, and now when I run pip3 freeze, you can actually see numpy is like installed. And these are like two separate environments. Joshua says, so is the virtual environment a Python thing or a Linux thing? It's a Python thing. It's a Python thing fundamentally. There's similar concepts in other programming languages that are managed with different programs. I'm sure, yeah, you could create a virtual environment, I guess, inside of a virtual environment. So this is all well and good, but this solves the problem, the second problem we talked about, which is how do we ensure your project doesn't end up with accidentally installed modules from other projects? And we've just shown you how you can isolate a project from another project, from your local directory, etc. So this is how you can just totally isolate things. But we didn't solve the first problem, which is how do I easily share the modules that I've installed with my team? And to do this one, it's actually quite straightforward. Is when you install a module, you can actually, there's a file. It's not a magical file. It's just like a file that tends to sit inside of a project folder, which we call requirements.txt. And inside of this, you can make this yourself. If it's not in your project, you can just go and create it. And this is actually just a list. It's actually just the output of pip3 freeze that shows all of the modules that you have installed. So we can go and create one of these for us, pip3 freeze, and output it to requirements.txt. Cool. So what's in our requirements.txt now? It's this. So after you install some requirements on your system, you can actually run this command pip3 freeze requirements.txt to essentially grab all of the things you've installed and package them up and put them in a file and then give them to your team members. And what you're meant to do with this file is you're actually meant to add it to Git. So if I say, if I add my numpy and my requirements.txt, and then I say, trying out package management, and then I push that to Git, now that is up on my Git repo for everyone else to get access to. There's actually this file here. And then what do your team members do? Well, let's just, as a demonstration here, let's actually delete my lecture demo folder and reclone it and show you how we can not have to manually install everything. So let me just go back to the clone. So now if I go inside of my lecture demo folder, great, and I go, what's the other command on the slides here? pip3 install -r requirements.txt. This is like a normal pip3 install, but instead of specifying a module, you say, actually, I'm just going to give you a requirements file, and I would like you to go and install all of those things. Did I not spell it right? Oh, I need to, I don't know. What have I done wrong here? Done something wrong. I deleted my virtual environment, I think. But I don't think that should have, I forgot to actually, here's a funny lesson here, right? I forgot to push my virtual environment to the Git repo. Actually, I don't think you need to. No, you don't need to. No, I'm pretty sure you don't need to. I don't work with Python on major projects much, so some things escape me. I must have just had a typo before. So you can actually see now that this is installing everything. But what's funny is because I'm not in a virtual environment, NumPy is actually being installed to my user directories. This is not being installed to a virtual environment. So I mentioned before that, you know, this is just to install the software, and then you actually need to create a virtual environment. I mentioned before you only need to do it once per project. In reality, probably what I should have said that's a bit clearer is you only need to do it once per clone. So like now that I've cloned this, I'm going to create like my own virtual environment for it. I believe you might be able to push some of this to the Git repo too. I haven't tried. You can play around with it. And then say I activate my virtual environment, and then I run my pip3 install -r requirements to go and install all the requirements that my team members have added to that file. That will go and install it to my requirements directory, to my packages directory. And then you'll see if I actually go and look inside of VM, lib, Python, site packages, that NumPy is there. So that's how I've installed it without having to go, you know, what version are you using? And the other problem is, you know, your friends might say, I installed NumPy, you go install NumPy, but you might have the wrong version. One of you might have installed it because you're running locally, the other one's running locally somewhere else, your other team member's using VLab, blah, blah, blah. It can run into some weird problems. Now, a very quick point here, because this is kind of relevant now and it starts to make more sense, is if we go back to lab 1 Python hello, there's actually a command in lab 1 we ask you to run, which is this particular command here, which is pip3 install this requirements file. Now, what this is this is actually just a web page that acts like a requirements.txt. And at the start of the course, whether you're using VLab or local, we essentially just said go and install all of these packages so that you don't have to worry about them. So all of these packages are installed by default on your like machine if you've run that command. So you can actually use all of these without having to pip3 install them. And we've actually got another file in a we've got more stuff in a file called requirementsextra.txt, which we don't, I think, share obviously. Well, like we don't obviously share it. It's not obvious to find. But you can easily just add, you know, modify the URL. Now, the real question is, what happens if you don't install all these modules? Well, nothing bad's going to happen. You could just install them yourself. Like, I think as part of this, we had PyTest, right? So that's why PyTest just worked for many of you, because you actually installed it with pip. But if you didn't install it, you could just install it yourself. The real question here, or the real thing to pay attention to, though, is that as part of how this course is set up, the GitLab runners that we use, the systems that actually run the GitLab code, like the pipelines, they only have installed on it these modules and these modules. So for the purposes of like this course, when you install a module, you need to make sure it's probably in one of these lists, if it's like not a very standard module. And if it's not in one of these lists, generally we won't like work with it, but some cases we will. We just need a really good argument. Typically, like for every 10 modules someone asks us to install, we might install one. But yeah, this is just like a list of all the packages that run on the runner. So if you install something that's not in this list, it'll work locally, but it won't work, you know, once you actually upload it to Git, which is equally as important. Last question before we wrap up this lecture. ArtSmart says, if you git pull in the virtual environment, can it be viewed from your local directories? Yes, I mean, the virtual environment does not change your file system. All it does is change where Python looks for modules. That's it. That's the whole thing. It just changes where Python installs where pip installs modules, and where the Python interpreter looks for modules. It's not an actual like. You can still look it up and stuff. It's not hidden away on the file system. It's just like that. So that pretty much brings us to the end of the packages lecture. The only last kind of point to make is just to kind of remind you about the different places that you can find packages on the computer. We've already touched on this today, but we have the built-in ones to Python, which aren't actually Python packages. Sorry, there's a lawnmower outside. They're not Python packages. They're actually built in and written in C. You won't find them on the file system easily. You can either have them installed with the sudo command at like a global level for the entire computer. You can have them installed in your home directory with just a normal pip3 install, or if you set up a virtual environment, you can install it in your project folder. And generally speaking, the question about do we need to set up a virtual environment as part of the major project, we're telling you that it's good practice and that you should. So I guess, yeah, because to not set it up is to not learn something and to make potentially life harder for your team members and stuff, particularly as things get more complicated. It's not something that we expect everyone to have set up for like iteration 1, because you know it's week 2 and it's like it's due in like 10 days or something. So that's all fine, but it's more like it's something not to ignore. It's not something you just say, I don't care about this, I'm going to forget about this term. But it's not something urgent. Here's some feedback. QR code, please fill this out. Again, it's super useful. I'll find the link so I can pass it to people in the chat. Whilst I'm just having a look at this, there was a question about how does C interact with oh my god, that lawnmower is so annoying. It's a small lawn out the front, so it's like gonna anyway. I'm just sending you a form quickly for the feedback, but the question is how does C interact with how do the C functions interface with Python? Oh, that's a good question. I don't know the full details, but you can look up like Python C bindings online is probably like where to go and learn more about it. There's probably a few different ways you could do it. Obviously, Python could invoke like a shell command that would actually run C, but I'm sure it might interface with it more directly. That's beyond my knowledge in this particular instance. And Caleb, last question: should we be putting the 1531 Pi packages in our virtual environment? What I'd say is if you ever install a module, I mean, you can do that. Yes, you can go and install that entire requirements.txt in your virtual environment. That's fine too. Though I think just for like fun and learning, it's really good to like just wait until you need a module and then it says that you don't have it, and then try and get into the habit of like, now I'm going to install it to my requirements.txt, because that's just like a good process to follow. So let's take a 5-minute break. That's the end of 2.4 and a little bit of that 2.3 at the end.